Hello everyone, my name is Nicholas and today I have the pleasure to present you the topic logic, which is contained in our WU BBE Entrance Exam preparation course on the most important quantitative concepts. To have an even greater experience, you will find complementary materials like more examples and solutions to the examples presented in this video for free on our website. The link is provided on this site, or you can just scan the QR code with your phone. Let's dive right into it. On logic, you will encounter on the BBE Entrance Exam. This video will cover all concepts you need to know to assess these statements correctly. For now, I suggest you stop the video and try this task yourself. Afterwards, at the end of this video, when you have learned all the new concepts, try it again and compare your answers. You will find the right solutions provided on the website, explained step by step. And now let's start with the first concept. When dealing with the logical tasks at the BBE Entrance Exam, it's very important to use logical operators. You might think you're able to solve these kind of tasks just with common knowledge, but typically you will make a few mistakes because it is not as intuitive as it seems in the first place. Nevertheless, it's pretty easy, and I will show you how to work with logical operators. There are a number of logical operators. I presented you just these 5. These 5 symbols are AND, OR, NOT, IF, and finally, if and only if. I will show you how to use them to assess if a statement is either true or false. For that, we need our operands, A and B. In our case, just as an example, these can take the values either true or false, denoted by F and T. I will show you how to use the logical operators in combination with the operands to assess if a statement is true or false. Now I will present you a truth table. This truth table is very helpful when it comes to learning how logical operators work. This column shows you if the logical operators A or B are either true or false. Now check the first case. The first case uses the logical operator NOT. Therefore, the first row, A is true. Therefore, this statement reads as not true because the symbol means not and A is true. Therefore, this whole statement is false. As you know, not true implies that a statement is false. When we move to the case that the operand A is false, this statement reads as not false. Therefore, it is true. The next logical operator we talk about is the logical AND. The logical AND combines 2 operands. For this statement to be true, as you can see, both operands need to be true. As soon as one of them or even both are false, the whole statement is false. In the next case, for the logical operator OR, I suggest you fill out the column of the truth table on your own and check if your intuition is right. Pause the video and I will just keep on. So, let's go through it step by step. In the first case, let's talk about when this statement is true. This statement is true as soon as at least one operand is true. So, meaning that also both operands can be true. And I guess if somebody got something wrong in this table, this is because of this true. This is why I said before, don't trust your intuition for logical statements. If both operands are false, the whole statement becomes false. Let's move on to the logical operator imply, or also called if. So, if A is true, it implies that B is true, meaning that if A is true, B must be true as well. Otherwise, this statement is wrong. as you can see in the second row. However, coming back to intuition, if A is false and B is true, this statement becomes true as well. If both operands are false, this statement becomes true. Now let's move on to the last logical operators of our set. This statement reads as if and only if A, then B. Try to solve this column on your own once again, and we will compare. The last logical operator is the logical if with double F. This statement reads as A if and only if B, meaning that this denotes logical equivalence. This is true only if both operands are the same. As you can see, in the first case both are true, therefore this bidirectional implication is true. The same holds if both operands are false. This statement becomes true. With this knowledge, we can move on and go through more complex tasks and translate the words like before, like in these statements, into logical operators and assess them individually. So, in this task, we have to choose the correct notations of the statement. If it's my birthday, there will be either cake or piñata. First of all, we start by translating this statement into a corresponding logical statement, using the logical operators we have learned about before and the 3 letters. In the next step, we go through each statement provided and compare it to the statement, if it's my birthday, there will be either cake or piñata. The first statement says, if it's my birthday, it will give cake and piñata. Therefore, this statement is wrong. His birthday and cake implies that there will be a piñata. This is not logical equivalent to our original statement. Therefore, this statement is incorrect as well. The next one says, cake or piñata implies that the person has birthday. However, this does not match the original logical expression. Therefore, the statement is false as well. As you can see, the last statement, if it's my birthday, there will be either cake or piñata, has all elements right. The implication is right, which is denoted by if, and there will. Furthermore, the or is right, and therefore our provided statement is equivalent with the last bullet point. Let's move on to the next task. In this task 1.5, we have to translate each single statement into a logical form. Let's denote M with meeting takes place and J with join the call. The initial notation, what we compare our statements with, is if the meeting is cancelled, I will not join the call. As you can see, this matches with the first expression. If is the imply sign. If the meeting is cancelled, meaning no meeting, we negate meeting, I will not join the call. So, if the meeting is cancelled, I will not join the call. Once again, the operand J is negated. In the next statement, if I don't join the call, the meeting is to be cancelled, meaning no meeting. If the meeting takes place, I join the call. If the meeting takes place, meaning that we do not negate the operand M, I join the call. If I join the call, the meeting is to take place. meaning that J is not negated. Just a J implies that the meeting takes place. Now, let's compare these statements to the initial statement provided from the assignment. Which of these statements is true? Take a guess. Sorry for the unfortunate color coding, but you know what it means. Just choose the statements which are true. I hope you have chosen the option correctly, because you just have to compare the statements. You took this one as true. However, you probably only took this one as true. You need to know about a little trick. The trick is called the contrapositive principle. The contrapositive implies that in an implication, like we have here, we can also state the form of this statement another way. The other way is that we negate both sides of the implication and turn the operands around. This is a calculation rule you definitely need to be aware of. If you don't know this rule, you just lose out on many points. As you can see, this statement is equivalent to this statement accounting to the contrapositive rule. Now, you might have seen that these statements match, meaning that not only the first but also the last statement is correct. Now, you need to know that you need as many points as possible for the BBE Entrance Exam. You should be aware of such little tricks, because as I talked to you before about intuition, you might get most of the questions right, but not all of them. But our goal is to get as many points as possible, meaning that we want to get all of them right, and we will succeed. This example deals with the if and only if operator. Before, we called this one if with double F. This operator, as you know, looks like this symbol. Now, let's turn this initial statement into a logical statement with its operands and the logical operator. A light, denoted by L, is on if and only if the switch is flipped up. In the next step, we have to assess each single statement, if they are either true or false. In this case, we deal with the if and only if operator. Let's denote the switch is flipped up with capital S and the light is on with capital L. As you know, the symbol for if and only if looks like that. So, I will give you a little hint. L, if and only if S, is logically equivalent to the following. L implies S and S implies L. So, based on this information, I ask you to translate each single statement down here into its logical form. Pause the video and assess whether the statements are logically equivalent, then they are true, or if they are logically not equivalent, then they are false. Let's translate each single statement into its logical form. If the switch is flipped up, the light is on. If the light is on, the switch is flipped up. If the switch is not flipped up, the light is not on. If the light is not on, the switch is not flipped up. Now you will probably start to use the contrapositive principle we have learned before. Rearranging this and rearranging this. Now you can see that we have our statements here and here in common. it's in common here and here, here and here, and for the fourth statement, S implies L, like on the right hand side. Now you might think that all four are true, but this is false, because the biconditional statement, if and only if, is only true if both sides are true. As you can see, it's combined with the logical operator AND. And as we have learned before, both operands need to be true in order that the statement is true. Therefore, all four of these statements are false. Now, coming to the final task 1.4, you have to perform the same steps as before. Now, you have multiple statements provided in the assignment, and again, multiple statements to assess if they're either true or false. The first step is to translate each single statement into its logical form. Then, you might to combine those to assess whether the statements are true or false. I hope you enjoyed the video. We won't cover the solution of this task. However, you have the possibility to find the step-by-step solution provided on our website. I hope you enjoyed this video on logic. You feel free to move on to our next videos from this video course and explore other quantitative concepts which are relevant for the BBE Entrance Exam. Either scan the QR code or click the first link provided in the description to get access to the solutions completely for free. My name is Nicholas, and I wish you all the best for the BBE Entrance Exam preparation.